This is fuel injection actuators video, and we're going to talk about 3 different actuators. We're going to talk about the fuel injectors, fuel pumps, and the idle air control, because those are the 3 basic actuators. So let's start with the fuel injector first. You can see from this diagram that the fuel injector, this is the intake manifold here, like it says, and this intake manifold, air is rushing in this direction, and this is your intake valve. It opens up, this goes into the cylinder, so then you'll have a piston down here. And so right at the top here, not drawn in here, is something called a fuel rail. That fuel rail supplies pressure from the fuel pump, what we're going to talk about in a bit, to the back side of this injector, so it's always there. This is where your electrical plug-in will come in. There's a couple wires that come in there to activate the coil windings. This is basically a solenoid, and so fuel is delivered here. You can see the fuel spraying out in this picture. This fuel spraying out is at the exact time when the injector is opening or activated by an electrical pulse. Good. So we're just going to look at a part of a wiring diagram that looks at one fuel injector. This is off 2009 Dodge Ram 1500 with a Hemi in it, 5.7 liter. And you can see right here we have the powertrain control module. That's the PCM. The PCM is the brains of the fuel injection system, and it gets inputs from other things. That's a different video. That's the sensors video. And it takes that information and makes a decision about how long to activate the fuel injector. And so you can see injector 2 control, and so brown and dark blue, and this leaves the picture, but it would come down here and go to this brown and dark blue right there, and it would go down through here and up this brown and white one. Okay, and then that brown and white one goes to where the computer, to a ground, which the computer controls. And so you can see this is a symbol here for a solenoid where we have current flows in here and goes around a bunch of windings and then out, and action happens. It's an actuator, so something physical has to happen, and that action is that the injector opens and allows fuel to spray in behind the intake valve. So the next actuator is the fuel pump. That's what we're going to talk about. This fuel pump sits in the tank, and there is on another video there it talks about the fuel pump a little bit. The fuel pump, the fuel itself comes through the bottom into the pump and past the motor. It's what cools the motor, and this is a actuator. The computer controls when this fuel pump is turning. This is our electrical connector here. There's likely 2 or 3 wires going into there. This is a one-way check valve. Fuel gets pushed up through it but cannot go back in, and that is to avoid long start times, long crank times when you're trying to turn the engine over. This is our little turbine impeller. This is what's spinning and creating a low pressure area, which causes a vacuum and sucks it in and then pushes the fuel out. How does that work? Well, this looks pretty complicated, but it's not. Here we have a wire that comes in. It's hot all the time. This is a fuel pump relay. Remember that a relay is a switch that uses a small amount of current, that's on this side, to control a large amount of current, which goes over here and runs the pump. And so what we have here is we have this is our ground. This is a ground symbol, and so power comes in here at exactly the right time from the PCM. It controls that, and current flows into this actuator and causes a magnetic field and makes this slide. Now this goes all the way to the ground, makes this arm slide over. So now current can flow down through here into the motor itself and down to a ground. That activates the motor. The motor is running. The turbine impeller creates a vacuum and sucks fluid into it, and then pressurizes and pushes it all through the lines all the way to the front of the engine, to the front of the car, and into the fuel rail and into the injectors, waiting for the injectors to open. The last actuator that we're going to look at is called the idle air control. An idle air control valve is pretty basic. On the inside they have something in here called a stepper motor. And that motor activates, it's got a bunch of little coils, and it makes this little button here push in and then come back, and it's able to move it in a short amount of distance and a long amount of distance and stop it whenever it wants. It's not a simple on and off. It can put this tip in any position, and so this idle air control fits down inside and seals up against a small hole, so it fits right up against there, and the further back the stepper motor is, and this valve, then the more air is going to rush through. If it's closer, then less air is going to rush through. Here's a wiring diagram for that. You can see that our actuator is down here. We've got a bunch of coils, and you can see that our PCM, it controls a high-low and high-low coil, and it can run this little pintle in tight. So you can see this is my throttle valve, and air is coming in here from my air cleaner, and it's going out to be delivered to all of the different cylinders. And when the throttle valve is closed, as it is in this picture, then current can air can flow past, and if we move this valve out in this direction, then there's more air can get past to the other side of the throttle. The reason why we want to control this is perhaps the air conditioning compressor kicks in and that pulls the engine down a bit, and so then this valve will move back a bit so that more air can go back past, and the engine RPM needs to compensate for that. And so it's going to do little things like that whenever your foot is off the gas pedal and the throttle valve is closed. Once again, the PCM takes all these other indicators, gets the information, makes a decision, and activates the idle air control to do exactly what it needs to do. And those are the actuators that we're going to look at from a fuel injection system.